For Process Document Access MES, Transactions, Manufacturing section select and open Product Engineering. From the list select the product for which you want to create the process document. In our example we are taking slide N store plus internal part number ending with 338. Process document is your control plan. Here you can define the route of manufacturing along with bill of material and other details. It gives you a exploded tree view of the main component and child components required. We have defined packet 1, 2, 3, and 4 as the child components for slide N store plus. We will take the example of packet 1 which has 2 sub-assemblies. One of the sub-assemblies lowest level goes through punching operation in notching department. Here in the process details we can define stage wait, queue time, rejection percentage, parallel run machines and production track required. Under machine and subcontractor we can define the priority machines with capacity and cycle time. Under material and sub-product we can define the bill of material. We can enter instructions, standard operating procedures along with images. Here we have attached tool setup, nesting drawing with part program and drawing for inspection details. Quality inspection can be defined for each operation. It can be pre-production, in process, quality assurance check or patrol inspection. The inspection can be measurement or visual, 100%, quantity per batch or lot, or variable. It can also be defined on time based in case of patrol inspection. Under measurement you can define the parameters to be monitored with min-max value, along with the type of measurement and gauge details for monitoring the calibration. Under other details you can define the visual checks or acceptable not acceptable parameters. The 2 child components defined get consumed in packet 1 at powder coating stage. Each component is loaded on the hanger in a sequence where the components get linked to hanger ID. At unloading there is a visual inspection done and the part moves to final fitting and packing. Once all child components are ready they are packed and weighed. At that stage a final barcode is generated with a checklist of items enclosed and moves to dispatch. In the FG area the final consumption is recorded for each packet. Work order can be imported from BPR for made to stock and made to order scenario. Select the Excel file which has been mapped for import. Once the data is populated in the grid, click on Fill Data and save. The data gets imported. Releasing orders for TOC, min-max, Kanban, items. For releasing order click select all items, each item will be marked yes, then click on release order. Scheduling of notching department based on plan. Under auto scheduling select notching department. Bottom section shows the current orders of TOC items released for notching. Here we select type forward and plan all. In case of type forward, it plans the items from next day first shift. Scheduling of other departments. Click auto scheduling and instead of selecting a department press cancel. By default all the balance orders to be scheduled are displayed for all items. In this case we have to select type process optimization powder coating. Once done, click on auto sequence. On the click of auto sequence button we can see the current powder coating loading sequence. Optimization has been grouped based on settings with order of priority. In this case it has sequenced based on color group, color, and weightage as priority and date group are same for all line items. You can select all and save. Once this is done, the auto sequence button changes to green in color, denoting that we are ready to run the plan. Click Plan All and Yes to continue the scheduling. Once the scheduling is completed, we can check the machine load chart in detail. Click on Machine Chart Detailed. Select the To Date. You can see the current load for each machine under all the departments. On the next screen you can see the optimization of powder coating department. In this example you can see the load on powder coating KD line. This can also be validated with a report giving the utilization of powder coating with expected color changeover per shift. Validation of plan. Under Auto Scheduling we can review the plan. Here we select example of Slide N Store Plus. For Packet 1, we can see that unloading is planned at 8:41 am. Powder coating is planned at 6:40 am as the queue time is 120 minutes for each component for unloading. Similarly, spot welding is planned to be completed by 6:35 am for both child components. 5 minutes is the queue time to transfer the material from spot welding to powder coating. This is ensuring minimum stock inventory between bedding and powder coating. Dynamic material requirement list is populated for the stores. Under Stores Raw Material Issue Plan you can see the list of bought-out items required for each operation, at each work center, at a specific date and time. In this example we require the door handles on 18 at 11:20 p.m. at powder coating KD line 2. The same can be extended to vendors in the vicinity for just-in-time delivery to ensure minimum stock inventory at our end. Once the material is issued it is removed from this list. The status is indicated with color for each stage. Production at Notching Department. For Pivatic 1, the operator can see today's plan which he has to follow for production. Accordingly he can also see what bought-out items or input materials are required. Based on the plan he can load the machine with specific work order. In this example we are taking the notching items for Packet 1 production. Once the work order is loaded, the operator can see process details such as notes or instructions and drawing details. Here we have attached the drawings, tool setup details required for production on Pivatic 1, along with nesting drawing and part program upload. The operator can also see the input materials and record its consumption. In the current example, since we have created a virtual environment, we are running a simulation to show that the machine is interfaced with MES. Once the machine is in production, on the supervisor dashboard, you can see online details of who the operator is, which product is being run, production count along with OEE and balance time to complete production. The operator can also request for help during production, which is displayed on the dashboard. An SMS alert or email can be sent based on these exceptions. Once the production is completed, the status shows the operator in idle mode, and in the simulation you can see that the production is completed. The operator can also see maintenance-related information such as machine parameters, machine documents, data of faults and possible solutions, JH check sheets or condition-based or time-based check sheets for maintaining the machine. Once the work order is completed, the operator can unload and take up the next work order. Once the production is completed on Pivatic 1, a communication is sent to AGV or internal logistics confirming that the material is ready. On the internal logistics screen, the same gets displayed. If there is no AGV, the internal logistics team will have tablets on their material handling equipment which will inform them of the next pickup and drop. Once the material has been picked up and dropped, in this case from notching department to ASRS in, the information gets updated in internal logistics. Now the material is ready to be uploaded in the ASRS for stocking. Once the material is delivered by the AGV or internal logistics, we can load the operation for bending as per plan. The operator can log in and see his plan for the day. In this example we have taken panel bender 8. Operator can also see the previous processes and its status for the current work order as per plan. Here at bending, we have enabled RFID tag for employee to load the work order. In a normal deployment, operator would have to scan RFID at each work center for accessing the MES. In this example we have selected the operator manually. Here operator can scan the barcode for work order and system will automatically load the selected work order for production. Operator can see process details like notes and drawings. Here we have enabled quality inspection. Operator can see the drawing and check the parameters with a digital gauge, or in some cases he can manually key in the results. If the parameters entered are out of range, there will be a warning message and an email alerts will be sent for this exception. In normal case of deployment, the machine will be stopped from producing further till a verification is done. The system will also generate SPC run chart and histogram which would be visible to the operator at all times. Pivotic to breakdown reporting. In case of a breakdown, the operator clicks Report Breakdown button. A call log is generated in the system with a reference number. An alert in the form of SMS or email is sent to maintenance. On the supervisor dashboard, the machine is highlighted as breakdown. Once the maintenance person arrives, he will log into the system and complete the breakdown reported. The operator needs to reconfirm the same by closing the complaint number.